Alright, let's take a look at this problem here. So we're told to design an op-amp circuit to perform the following operation. So we want to have the output voltage equal to 3V1 minus 2V2. Okay, so immediately when we look at this equation, we see we need to add two different inputs. So we're combining one here and one here. So in order to combine them, we can use a summer. So we need to have an op amp that will allow us to add two different inputs. But these inputs are actually going to be, we can design it to be a voltage source coming in, or we can use another op amp coming in here. So what we're going to do is we're going to use an inverter. We're going to use an inverter and a summer to design this. Okay, so one way to look at this, if we're going to use an inverter, the equation for the inverter is V output equals minus R feedback resistance over R input resistance R1 times V1. And for the summer, if we're going to use the summer here, we have two inputs here. So we'll assume we have two inputs. Our V output is going to be equal to minus our feedback resistance over R1 times V1 plus our feedback resistance over R2 times V2. Okay, so these are the two equations we're going to be dealing with to come up with that final output equation. Okay. Furthermore, it's saying the resistances need to be less than 100K. That's less of an issue here. We can design it to be a generic op-amp circuit. Okay, so let's go ahead and work backwards. So let's look at our summer equation. So let's look at this equation here. Okay, if we look at this equation, technically our V1, if we define it this way, so let's just go ahead and highlight this. The output from our inverter, this guy, should go in here. Okay, and then that would take in place of, so this V1 we can say is so let's go ahead and rewrite this. Let me rewrite this here. So if I rewrite this, my V output is going to have to equal RF over R1 times V1 minus RF over R2 times V2. Okay, that's what we're going to have to come up with. And then I can look at this and say, well, my ratio here, this should be 3, and my other ratio here, this should be 2. So that's one way of looking at, one way of solving this problem. Okay, it's very generic, but let's go back and we don't necessarily have to put values in here. We could and test it out, but that's one way of approaching it. The question is, how do we get this? How do we get this here? So let's rewrite this. Let's go back and look at it in a different way. Let's just say, okay, if I have my V output, I'm going to define my RF over R1 times minus V1. That's from my inverter equation, plus RF over R2 times my V2. Alright, so the negative sign is going to transfer over here, negative here, and that's how we came up with this guy here. Okay, we can further look at this equation here, where we have RF over R1 should be 3, and we can say, well, R1 technically should equal to be 1/3 RF, and our R2 should be 1/2 our RF. Okay. To make it even more generic, we can say, well, I want to treat each resistance as the value R, and I can say, well, my V output equals minus R over 3 minus V1 plus R over 2 V2. Okay, so these are all different methods of coming up with our final required result. But now the question is, how do we design it? So let's go ahead and draw. Let's go ahead and draw this here visually. So we're going to have our inverter coming in first. So we got V1 coming in here. We have our op amp. This is grounded. We have our feedback resistance. Let's come back here. And this is going to give us minus V1. And then we're going to have two inputs into our summer. One here and one here. We're going to call this V2. All right. I'm going to put these guys in here. Coming in here, plus this is going to be grounded. This is going to be my V out, and we're going to have a feedback resistance here. Okay. So you can draw it this way. Do this guy here as well. So that's how my circuit would look like. Now, essentially, so we have our V1 coming in here. It's going to get inverted, and then this inverted V1 plus V2 for our summer here. So this is first portion is our inverter. Second portion is our summer. Okay. And then we can just plug in generic values in there. Like I said, if you come up here, we can define our RF here as our feedback resistances, our R1 here, R2 here, or we can use this generic form. If we wanted to, and then just say, well, my resistances are going to be R out here. I'm going to have R over 3. This is going to be R over 2. This is my feedback R, and that would be how I design this circuit to come up with this potential equation. Okay.